This is an Olympiad-level logarithmic equation. Let's solve it. We have x over 2 to the power of log base 2 of x equals 8x. The first step is to take the log base 2 of both sides of the equation. So you write log base 2 of x over 2 to the power of log base 2 of x equals log base 2 of 8x. Now, we have to use some basic logarithmic properties. We see that we have log base 2 of something to the power of something. And if you remember, log base x of b to the power of a is a times log base x of b. In other words, we can take the exponent and put it in front of the logarithm. In our case, the exponent is log base 2 of x. And on the right-hand side, we see that we have log base 2 of 8x. 8x is nothing other than 8 times x. And log base x of a times b equals log base x of a plus log base x of b. So let's rewrite our equation. We have log base 2 of x, which is this exponent, times log base 2 of x over 2 equals log base 2 of 8 plus log base 2 of x. Now, we have log base 2 of 8. How much is it? Well, it is 3, because 2 to the power of 3 equals 8. And here, we see that we have log base 2 of something over something. And you remember that log base x of a over b equals log base x of a minus log base x of b. So let's keep simplifying our equation. We have log base 2 of x times we have log base 2 of x, which is the denominator, minus log base 2 of 2. 2 is the denominator. And this equals 3 plus log base 2 of x. Now, how much is log base 2 of 2? Well, it is 1, because 2 to the power of 1 equals 2. And now we see that we have log base 2 of x here, here, and here. So, in order to write a little bit less, write down that y equal log base 2 of x. This will simplify our lives a little bit. We thus obtain y times y minus 1 equals 3 plus y, which is a simple quadratic equation. We get y squared minus y minus 3 minus y again, because I transferred those two terms to the left-hand side of the equation, equals 0. Or y squared minus 2y minus 3 equals 0. If you need a reminder how to solve quadratic equations, you can watch this video, but I'll just show you the solution here. y1, 2 equals minus the coefficient in front of y, which is minus minus 2, or just 2, plus minus square root of the coefficient in front of y squared, which is minus 2 squared, minus 4 times the coefficient in front of y squared, which is 1, times the coefficient that doesn't contain y or y squared, which is, in our case, minus 3. And this whole thing is divided by 2 times the coefficient in front of y squared, which is 1. Or we thus obtain 2 plus minus square root of minus 2 squared, which is 4. Then we have minus 4 times 1 times minus 3, which is plus 12. And we have to divide it by 2 times 1, which is 2. Or we get 2 plus minus square root of 16 over 2, which is 2 plus minus 4 over 2. Therefore, the first solution, y1, is 2 plus 4 over 2, which is 6 over 2, or 3. And the second solution is y2 equals 2 minus 4 over 2, which is minus 2 over 2, or minus 1. But we want to solve our equation for x. So we go back here, and we write down that log base 2 of x1 equals 3, or x1 equals this to the power of this, or 2 to the power of 3, which is 8. And we also write down that log base 2 of x2 equals minus 1, or x2 equals this to the power of this, 2 to the power of minus 1, which is 1/2. And that's it.